So now that everything is defined, so the next step is the mesh module. The mesh module is probably the most important, one of the most important modules actually, and this is where you can tell actually the difference between a professional and just a beginner user of finite element. So you have to make your mesh the proper size, the proper dimensions. You shouldn't have like any distorted mesh elements. So you need to make sure that everything is correct. This will make it easier, of course. Once you start running the analysis, you will not get errors, you will not get problems with conversions and so on. Of course, we did like the most preparation work as part of the partitioning that we did for our different parts. So now our task becomes easier right now for doing the meshing. So right now we're in the mesh module, and over here these are all the different icons that we are going to use to define our mesh. So basically right now I see the assembly. So right now this is what's selected, the entire assembly, but we are not going to mesh the entire assembly in one shot. We are going to mesh each part individually. So this is similar to what we have defined earlier when we defined the instances. We said that we are going to mesh dependent on the part. So if I go here and click on part, so now I can toggle between the different parts, and I can define my mesh. So let's start with the beam perhaps, because the beam is the shell element, and perhaps this is the easiest one to do. So what we need to do with respect to the mesh, we need to do a couple of things. We need to set the size of the mesh, the type of the mesh, and the controls, perhaps like how the meshing, what mesh algorithm would be used to measure the part. The first two, the size and the type, these are very important. The third one, the mesh algorithm, this is only you need to define, or perhaps you need to go into this if you have some complex shape or you are not getting the proper meshing in your part. So let's start first by the size. So in the size you have these two controls over here. So the first one is the seed part. Okay, so this, if you click on it, you can create seeds. So seeds meaning you need to define like the nodes that constitutes the corners of your mesh element. So what would be the size of these mesh elements? And over here, this other icon, this is seed edges. So if you want to, the first one is pretty much the global seed for the entire part, but if you want to seed or specify the mesh element, or the by size or by number for a specific location, then you use the second one. So let's start with the first one. This is the general one. So you click here, then you get this dialog that tells you what would be the approximate global size. So the global size, well, this depends on your dimensions over here. So right now I have, if you remember, we have the width of this flange, if I remember correctly, was like about 120 millimeter. So this means half of the flange is 60 millimeter. So I think if I have like 3 or 4 elements across half of the flange, that would be a reasonable size. So roughly, if this is 60 millimeter, if you divide this by 3 or by 4, you get around like maybe 15 millimeter. So I can set here the global size as 15. The other things, those are for curvature control and pretty much so that you don't get any distorted mesh elements. So I can leave those as they are. You don't need to play with those. The default values would, in most cases, are just fine. So before I click OK, I can just click apply to see how this look like. And you see here, once I click apply, you can see an indication here of the mesh elements. So as you see here, these are the points. So you see that half of the flange will be divided into 4 elements pretty much. Okay, and the same thing in all the directions. So pretty much these dimensions are roughly 15. Okay, so the algorithm works like in order to make the approximate global size. That's why it says approximate over here. So that seems fine, and then I can click OK. All right. In the same time, if I want to modify, perhaps I want to decrease or increase the number of elements across the edge, then you can do the seed edges. So if you click on that, then you can select the edges that you want to modify. So let's say I want to modify these edges, for instance. So I select all the edges. Of course, you want to select all the edges in the same direction, because if you modify ones and you don't modify the others, then you are going to get asymmetric shapes of meshing, which doesn't look nice. And then I can click on done, and then here I can specify exactly like what would be the size across these edges. So instead of 15, perhaps I want to make it more, because I don't need more the size here. I can relax it more in the longitudinal direction. Perhaps I can specify this by number. So I can say that, okay, across this length, I want exactly to have 50 or 30 elements. Okay, so I can be very specific. And actually, if you go to constraints over here, if you go to constraints, whatever the value that you specify here, if you specify this by number, you can allow the meshing algorithm to modify this number in order to accommodate other things in the algorithm. Or if you want to be strict, you can say, okay, don't allow the number of elements to change. So I want those to be 30 elements exactly, assuming that this is what you want. So you can modify that here if you want by using the seed edges. But for now, I don't want to do that. I will just leave the global one. At the same time, if you did seed any of these edges and then you changed your mind, by clicking on this icon, you can select this second one, and then you can delete the edge seeds. So you can select the same edges and then you delete whatever that you have specified earlier. So that's with respect to the mesh size. So that's fine. Now the second thing that we want to do is to assign the mesh element. So this is the icon over here. So this one, assign mesh element or element type. If I don't select this icon, by default, you are going to get the default type of mesh element for your part. So my part is made of shell. So you are going to get the default shell element. And in this case, the default shell element is the linear shell element, which in ABAQUS, it has the abbreviation S4R. So it's called S4R in ABAQUS. But in any case, I always encourage myself and all my students to always go through this step, even though by default, let's say that we want to use S4R anyway. But in any case, I recommend you to click on this icon and do this yourself as well. So if I click on that, I need to select all the cells pretty much, or the regions that will be assigned this. You see here now I'm not selecting anything, because if you remember, we changed this select entities to select only things inside that are fully inside the box, selection box. So I need to revert this back to the other options. So anything inside or crossing the drag shape or the box. So now let me select again everything and I say done. And then, so right now the element library, so we are going to use ABAQUS standard, which is the implicit solver. Okay, there is always there is the explicit solver. So this is if you are using ABAQUS explicit solver, if you are doing, like, for instance, dynamic analysis or something like that. And here the family type shell. So this is already by default selected, because ABAQUS already knows that this is a shell part. And then the geometric order, is it a linear element or is it a quadratic element? So I'm going to use linear element, and I'm going to use the one with reduced integration, and this one is labeled S4R, and actually this is the default one over here. So S4R is a 4-node doubly curved thin or thick shell that has reduced integration and hourglass control, and it is very good in capturing like bending, deformations, and so on. So I'm going to use the S4R. If I want to use the quadratic, if I click on quadratic, this will be the S8R. Of course, this will take more time for computation because it's a higher order element. So I'm going to use again the S4R. There are other options over here regarding like second order accuracy, element deletion, hourglass control, but for everything here I'm going to use the default. But again, if you want to explore these things and try to play with those options to see what those do, you can do that yourself. So I'm going to say okay. So that's it. I'm going to say done. And over here, that's it. Everything has been done. And over here in the message box, it says global seeds have been assigned. The third thing, if you remember, we said the size, the type, and the mesh control. So we did the first two. Here you have the mesh control. So the mesh control, you can click on the mesh control. We don't need this here because actually we have a very regular part geometry, so it's not really critical. So, but anyway, let's do it. If I select all of this like that and I click done, so you can tell ABAQUS which algorithm should you use, all right? So there are different techniques, and for each technique there are different algorithms under that in order to accommodate the different geometries and produce the most proper mesh. You can read more about these techniques, and I think the best way to do it is to try those techniques yourself, trying to change them and see what each one will produce. And by experience, you will find that specific types of techniques and algorithms produce the best mesh for these specific cases and so on. I'm going to use the alt one in this case, which is the free technique, the advancing front, because again, I have like this regular part, nothing unique here. So this is what I'm going to do. Of course, the element shape, this is a quad, meaning like it has 4 corners, so I keep it as it is. So I'm saying okay, I go with done, and then the last thing is to actually mesh the element, which is this icon over here that says mesh part. So I just click on mesh part, and then ABAQUS is telling me okay to mesh the part. Yes, go ahead, and then click yes. So right now you have the part meshed, and as you see here, it looks very good. Maybe I can remove from the part display options, I can remove the extrusion. So as you see here, everything looks proper, everything looks square. The aspect ratio, very important to check the aspect ratio. So the aspect ratio of the shell elements are like very close to a square, so that's the best thing that you could do. So now everything looks good. So now let's move to the second part. Let's go for the second easiest one, the end plate. So here is the end plate. Let's follow the same procedure that we did before. So I'm going to select the seed part, and then I'm going to define a global size. So here I'm not going to use a smaller global size because right now I have these holes, and these holes will have, if you remember, the diameter of these holes or the radius of this hole was about 9 millimeters. So if I want to see like maybe 3 cells or 3 elements across 1/4 of this radii, then perhaps I want to go with a smaller mesh size. So perhaps I can use 3. And this is also important because I'm expecting I can decrease the mesh size here for my plate because I'm expecting this plate to deform a lot. Like this is the weakest element in my connection, so this will deform a lot. So if I'm expecting lots of deformation, so perhaps I need to use more finer mesh. So I can click on 3. Let's see how this looks. I can click on apply, and then here is how it looks. Yeah, it seems like actually lots of mesh elements. Maybe we can decrease it a little bit if we want. Maybe I can try 4. Yeah, 4 seems reasonable. I can click OK, and that's it. So now we have it. If you want to be specific about the number of elements again that you need to have for a given edge, then again you can do that. Notice again when we did that, let me click on this again. So across the thickness right now, for instance, you have 3 elements. So you will have 3 elements across the thickness. If you don't want that, if you think that this is too much, you can modify this. So again, you can close this. You can go to the seed edges. Let's look in the YZ plane. So now I have the YZ plane, and now I'm going to select all the inner edges. So here, right now, Let me go to the 3D again. So now I selected all these inner edges, all right? And then I'm going to click done. And then I'm going to tell ABAQUS that actually I don't want, so you see right now it is 3. No, I want it to be 2. And I'm going to go to the constraint. I'm going to say don't allow this to change. I actually want it to be exactly 2. And then I can click on apply. And then I can click on OK. Of course, before I click OK, like if you zoom, you see that right now this has changed. So now you have 3 points, or basically 2 elements across the thickness. Okay, because I have like a very small thickness, so maybe I don't need that much. And then I can click on OK. So how can you tell if the mesh size is correct or not? Well, this is like by experience, you get to know what would be the appropriate mesh size, but ideally, of course, this is a matter of weighing computational time, okay? Because if you do more refined mesh, then this you increase the mesh, the computation time, but in the same time you can get more accurate results. But at one point, the accuracy of the result doesn't change after a certain level. So in general, in finite element, typically you would like to do a mesh sensitivity study in order to find the appropriate, or the optimum, that's the word, the optimum mesh size in your model. So that's it. We've done with the mesh size. Let's go for the mesh element type. So again, I'll select all the mesh type. I'll select all my cells. I'll click on done. And again, I'm going to use the standard library linear elements, and I'm going to use actually this C3D8R, which is a brick element, a solid brick element that has 8 nodes with reduced integration and hourglass. So this is the one I'm going to use. Again, a linear one. Perhaps I can check again to try to run it with a quadratic and see if this changes my results, depending on the case, of course. So I say okay, that's fine, done. And the final thing is the mesh controls. So let me check on the mesh controls, and let me select all the elements, right, the cells in my model, and click done. So right now it says structured. So this is the default in this case, would be structured mesh. Let me click on cancel actually, and let me mesh the part. Let me see by default what would be the mesh shape or the mesh will look like. So I can click on mesh part. Yes. So this is how it looks like. So actually it looks very, very nice. And in our case, like I can look here in the, so now you see like 2 elements across the thickness. The mesh elements, they look very nice. If I look here around the bolt, everything looks fine. Yeah, perhaps it's not very symmetric around the hole, but overall it looks nice. And the reason why it looks nice, even with the default mesh technique, is that we have partitioned our part very well. If we didn't do that, you are going to get like asymmetric shapes of mesh grid, and it will not look this good. But anyway, the best actually mesh control that you can do, let me do again another technique here. I'll select everything and I click done. In general, what I prefer to do is that whenever you have like holes or circular patterns, is that you use the sweep technique, and the algorithm you use the medial axis. Okay, so when you do that, this is in general the best, one of the best algorithms when it comes to having holes or circular geometry. So if I click OK, so now ABAQUS is telling me okay, if you do that, this means that you are going to delete the current mesh. So yes, that's fine, delete the current mesh. All right, done. And now, since I assigned this, let me mesh the part again. Yes. So it perhaps didn't change anything. It's more or less the same. Okay. All right. So, but anyway, this is because we have done the partitioning correctly. So you can play with the different meshing techniques to get an idea what each one does. So that's it for the end plate. Now let's go for the next one. That is the column. So the column is perhaps the most complicated part, because it has lots of curvatures because of the fillet radius and the holes that we have over here. So, but let's go ahead and see how the mesh will look like. So let's start by doing the global seed. So what will be the global seed in this case? So again, I have the holes here. So because I have the holes, so perhaps I will go again with a 4mm global size and I click apply. But you see now you will get like too many mesh elements, because right now you have your entire model will have this global size of 4, which is mainly controlled, like we are using 4 here because, as we said, near the holes I want to have this number of elements across the radius or the diameter, the perimeter of the hole. Perhaps this is not the best way to use that. So actually what I'm going to do, I will cancel this. And what I will do another partition. I will go back to the part for the column. I will do another partition like at this location and another partition at this location. And then I'm going to assign a different mesh size for this location and different mesh size for the outside areas. Okay, this would be the best or the optimum way to do that actually. So let me go back to the part. So I go back to the part. We can create a partition. So let's say how we are going to create a partition here. So perhaps we can create this with a datum plane. So I can create this with a datum plane. Let me create a datum plane first. So I will do a datum plane parallel to XY, and the offset will be well, half of the column, which is over here, which is 1500. The column was 1500 length, so this is 750. And then I'm going to do another partition, perhaps at the end, at the location where I'm going to have the end of my end plate. So half of the end plate height. So the end plate height, half of it was 140. So 140 plus 750. So that's it. I have a partition over here. Let me do another one. So that would be 750. So by the way, you can write expressions here inside this window over there. So 750 minus 140. And then I have the other partition. Then I'm done. Now let's partition this using the datum plane. So I'm going to select all these ones, these cells over here, done. And then I'm going to select the partition plane. And then I say create partition. Then I'm going to select those cells, say done. Then I'm going to select this partition plane, click done, and that's it. Let me check to go in the property module just to make sure that everything is green, because sometimes when you do these cuts, perhaps you need to reassign the section property, but now it seems that everything is fine. Let me check the assembly to check that everything is in place. Yes, everything is correct. So now you see the partition is pretty much flush with the end plate, so this is better. So now let's go back to the meshing. And now, as you see here, when I'm showing the assembly, right now I have the end plate meshed, I have the beam meshed, but I still didn't mesh the bolts or the column. So let me select here from the part the column again. So now I'm going to do a global mesh of 4. I'm saying apply, okay, that's fine. And then I'm going to change the seeding for the rest of the column. So if I look sideways like that, I can select all these edges over here and all these edges over here. So now let's look again in the 3D. So I'm clicking on those ones and I click done, and I perhaps can reduce the size. So in this direction, perhaps I can go back to maybe 12 or something. Let's see, apply. Yeah, that looks better. I can click OK. Done. I can modify the rest as well. I can modify the other things across the cross section, but let's keep it like that for now. So now we're done with the mesh size and the seeding. Let's go with the mesh element type. So again, I will select the entire thing. I click done. Again, I'm going to use the same linear C3D8 4R, and I click OK. Done. And then the last thing is to do the mesh control. So actually, let's do this now by using the default option, which is the free meshing. So let's click on the mesh. Let's mesh the entire part. Let's see how it will look like. So now the entire thing is meshed. You see that like there are too many mesh elements, and you see here like you have approximately 4 across the thickness, which is a little bit too much, especially that I'm not expecting the column to deform a lot. And actually here you see across the holes it looks very nice, the mesh looks very nice and very symmetric, so that's a good sign. But again, this happened because we have partitioned our column very well. So I'm not going to accept this. I want to actually to reduce the amount of mesh elements across the thickness. This is too much. So across the web I have 2 elements, which is fine. So I'm going to do the same across the flange. So let me click on the seed again. Let me look in the YZ direction, and now I'm going to select all the elements. So I'm trying to select within the thickness of the flange. So here I selected this one. I click shift and click the other one on the bottom flange. Oops, I select another one wrong. That's fine. I can click control and reselect, so to unselect, then shift, and then I select again. Let me do it here, very small box, so I'm not selecting anything outside. That's it. So right now I select all the interior edges, the vertical edges pretty much. All right, so now I have all these vertical edges, and then I click done, and then by number I want this to be 2 and don't allow this to change. So let's say apply, yes, delete the current meshes. All right, okay, and done. And now let's try to remesh again. So right now you see you have 2 elements across the thickness. That's much better. Okay, and here this is more refined. We could have probably reduced the number of mesh elements as well across these edges, but let's keep it like that for now until if we find that our model takes long time or we want to reduce the time, again we can make our mesh a little bit more coarse to save on computation time. So I'm done here with the meshing of the column. Let's go back to the end plate. So right now, by the way, here it's telling you how many mesh elements have been created in the column. So you see like there are too many mesh elements actually, which it can be optimized, but for the sake of our analysis right now, let's keep it as it is. So let's go to the bolt. So this is the bolt again. The first thing, let's do the mesh size. So this is the bolt I'm going to use, perhaps like a little bit smaller, maybe 2 millimeter. Let's say apply. That looks nice. Click OK. The mesh element type, I will select everything and I say done, and then yes, linear C3, yes, I'm going to use that. There are different ways of meshing the bolt. I'm going to discuss this in a second. So this is done. Mesh control, let's check first the default. So mesh the part. Yeah, so this is how it looks like. You see like there are some distortion over here. Okay, so this is not ideal to have this kind of distortions. So perhaps I can check the mesh control, reselect my cells, click done, and the technique, let's go with the sweep medial axis, and let's go with OK, delete, and let's try to remesh again. Let's hope that this will fix that. Yeah, so right now you see with the medial axis, now I don't see this distortion and the bolt looks much better right now. Everything looks symmetric. There are actually better ways to, like this meshing is fine, but there are even better ways to mesh a bolt. So like actually if I go back to the part, you could do a partition here as well, a circular partition across the head and across the nut. And in the meshing you can use wedge elements. So wedge elements, they are triangular elements pretty much that you can use across the shank of the bolts when you have cylinder shapes. So this is typically a better approach, but for the sake of this introduction tutorial, we'll just keep it as it is right now with the regular elements. So if I look now in the assembly, yes, so this is how the assembly looks. So everything looks fine. everything is meshed, everything looks proper. So right now we are done. By the way, so before I finish that, so if I go back to any of my elements, for instance, there is something that you can do. Let's say that you have a part like the column and you're not sure if all the mesh elements are good. Maybe there are some of them are not that good. So you can check the mesh in your model by going over here, verify mesh. If you click on that, you can select the regions that you want to verify. So perhaps I want to select everything here, click done. So you can tell ABAQUS here to highlight any elements that has, for instance, an aspect ratio greater than 5, or that has a corner angle less than 30 or greater than 140. So this is the default limits that ABAQUS have for a good mesh, but you can be more strict if you want. So if I click on highlight, there is nothing, and actually over here it says that the average aspect ratio is 2.6, which is not that bad. Ideally 1 would be the best, of course, but 2.6 is not that bad for this type of mesh elements. Here it's telling you like summary, like what is the worst maximum angle, what is the worst minimum angle, but for the criteria that we selected, we actually have 0 errors and 0 warnings, so there is no problem here. All right. Of course, if I relax or not relax, if I make this more strict, so let's say I don't want any aspect ratio to be more than 2. Now, if I click highlight, now you see all these elements does not pass this criteria because they have an aspect ratio more than that. So now ABAQUS highlight it, and then you need to modify it if you want. So let's go back to 5. So that's okay. Yeah, because if I zoom here, these mesh elements actually are not ideal because you see they are like elongated in this longitudinal direction. So ideally you want the aspect ratio to be as much as possible as a cube. All right. But anyway, that's fine for this case. I don't think this will affect the results or anything because most of these mesh elements outside the connection part are not going to deform anyway. So dismiss, but anyway, here you can do many things like shape metrics, size metrics. You can highlight if you have like an element that has a very, very small size. You can do all types of analysis check to make sure that your mesh is correct. So now that we are happy about the mesh, we are done with that. The last thing that we need to go to is submitting the job, which what we are going to do in the next video.